Here's a problem with a dog and a cat in a race. Whenever there are two objects in a race, there are certain things that will be the same, like, some time. They might have the same time. They might be traveling the same distance. So those are things to pay attention to. It helps me think about the problem when I draw a picture. So I've read the problem. I'm not going to go through it, but there's a cat here. It's asleep at rest. And it's 1,500 meters from the finish line. A dog passes the cat. And so here's the dog. And then the dog goes on its own for 2 hours. So it doesn't cross, but it makes some distance here. That's 2 hours worth of distance for the dog. Now the dog's not done. It still has to finish up the race. Okay, so we know the dog's speed, a steady pace of 15. The dog is traveling at a constant speed of 15 centimeters per second. I'll convert that to meters, 0.15. And we have to find the minimum acceleration if the cat wants to beat the dog. So we're looking for the acceleration of the cat. Now, the cat will travel this distance in the same time that the dog travels this distance. I know I need to use the big four equations to find the cat's acceleration. But right now I don't have enough information. I know the VO is 0 because the cat starts at rest. I know the distance is 1,500 meters. And the start position of the cat we could call 0. But I need something else to find the acceleration. This alone is not enough to start using the big four. So you might be able to guess we can find the time of the cat. The way we find it is by determining how much time the dog will take to travel this last leg. So how do we find that time? Well, whenever an object has constant speed, like the dog, we can use the equation speed equals distance over time. But wait a second. We know the dog's speed, and we know 2 hours is one of the times that the dog travels. 2 hours in particular is the time for this part of the trip. Let's plug in that 2 hours along with the speed to find the distance in green here. Okay, so I do 0.15 meters per second. For the time, I can't put hours because the denominator of the left side is seconds. So I convert that. 2 hours has 60 minutes, and each of those 60 minutes has 60 seconds. I cross multiply. And what do we get for distance? Let's turn on our calculator. 0.15 times 3600 times 2 for the 2 hours. 1080. So that's the first leg of the dog's trip. What's the purple distance, the second leg of the dog? That's going to be the total minus what the dog has already done. And what's that going to give us? Well, 1,100 would be 4, so 420 is the distance. We can do that on our calculators. Okay, so the purple distance is 420 meters. We need to know the time it takes the dog to travel that 420 meters. So we use this equation once more. Let me show that work. Okay, again, we know speed is equal to distance over time whenever speed is constant. This equation applies to the dog because the dog has constant speed. What's that constant speed? 0.15 meters per second. This time, we seek the time t, and we know how much distance the dog travels on that second leg. When I go to solve for t, I have to get it out of the denominator. So my first step is to multiply both sides by t. This will cancel t from the right side, and I have 0.15 meters times t equals 400, meters per second, pardon me, equals 420 meters. We divide both sides by the 0.15 meters per second, and what do we get? 420 over 0.15, 2,800. We now know how much time the cat has to travel that 1,500 meters. It has to go 1,500 meters in the same time that the dog travels this last 420 meters. So now we have enough information to use a big 4 equation. The equation we pick is the one with all of those variables. It's x equals xo plus vot plus 1/2 at squared. This is 0, so it goes away. VO is 0. Anything times 0 is 0, so that's all 0. And we'll just have 1/2 at squared. So to solve from here, we plug in our values. 1,500. A is the unknown. And t is 2,800, which is getting squared. We'll be multiplying both sides by 2 to get rid of the 1/2. 2 over 2 is 1. That cancels out. We've got now 3,000, but we need to divide by the 2,800 squared. And when we do this on our calculator, let's just do second answer squared. We get 0.00038, and that's exactly the answer. Or 3.8 times 10 to the minus 4 meters per second squared. On to number 2. A car traveling along a highway passes a van, stopped on the side of the road. Okay, so again, I'm going to draw a picture. Here's the van that's stopped. Looks more like a delivery truck. That's okay. Here's the car. Okay, after the car has traveled 1,000 meters, let me draw that. Here it is 1,000 meters later. 100 meters. The importance of reading the question. Here's the car now 100 meters later. The van pulls back onto the road and begins accelerating uniformly at 0.0324 meters per second squared. After half an hour, okay, so that's a time, the van catches up to the car. Okay, so now in half an hour, both are traveling. So let me show that distance. Here's maybe how far the van goes. Here's how far the car goes. That time for the blue arrows to occur, that time is half an hour or 30 minutes. Each minute contains 60 seconds. Okay, that's the time for the blue to occur. And at this moment, they are at the same spot. So there's a distance or a position that's equal, right? We also know the van starts from rest. Okay, let's see what the question is asking for. Calculate the car's speed in miles per hour. Well, hang on, we know the time for the van. 30 times 60, the zeros go there. 3 times 6, that's 18. We know the acceleration, the speed, the start position is 0. So we can find how far, already we can find how far forward the van has gone. Let's do that calculation. We use x, it's the big 4, because we're dealing with acceleration. That's how we know it's the big 4. This is 0. VO is 0. And 0 times time, no matter what the t is, that gives 0. So we know x, that's our unknown. That's what we're looking for. Acceleration, 0.0324 meters per second squared. We're squaring the time. So the seconds squared will cancel with those seconds squared. That's 1800. And we calculate. 1/2 times 0.0324 times 1800 squared. And this is 52488. Okay, so is that the distance that the car travels? Well, not quite. The blue distance is not quite the same as this blue distance. In particular, if this from here to here, if that's the van, that's how far the van went, what's this value right here? Well, it's just 100 less. 52388. Right? So now we know the distance of the car, we know the time, we can find the car's speed. The car's speed is constant, so we can use this equation. Again, we know the distance the car travels for this last leg. We know the time it takes the car to travel that last leg, so we can find the car's constant velocity, or speed. We plug in the distance, we plug in the time. What do we get? 30 times 60. So let me do that here. I'm going to do minus 100. That's how I got the earlier answer. And then I divide by 30. And I also have to take that numerator and divide it by 60. 29. Now that's meters per second. They want the answer in miles per hour, right? Calculate the speed in miles per hour. So the final step, is to take that speed, 2.91 meters per second. Every time we convert, we multiply by a fraction that's equal to 1. We have to make sure then that the numerator and denominator of each fraction, they have to equal each other so that the whole thing is 1, the whole fraction. Okay, so I know I'm going to have to cancel out meters, right? So that'll go on bottom. I know I'm going to have to cancel out seconds, so I need that to be opposite the seconds here in the denominator. So these seconds will cancel, those meters will cancel. I want to convert into miles, and the seconds I want to change into hours. Okay, now I can't put 1 and 1 because 1 mile doesn't equal 1 meter. But what do we know? Well, 1 mile equals 1609 meters. And this fraction is equal to 1. I'm not changing the value by multiplying with this fraction. Okay, the meters cancel, and I'm left with miles per second, but then I cancel out the seconds here. So I can't put 1 and 1, that's wrong, because 1 hour doesn't equal 1 second. What could I put? 1 hour is 60 minutes. Each minute contains 60 seconds. We multiply the numerators all together, we divide by all of the denominators, and what do we get? Oh, this is 29.1, not 2.91. Okay, so I take my answer here, times 60 times 60. I divide by the 1609 in the bottom, and I get 65 miles per hour. And that's the answer.